Hello class, welcome back to another section of our intensive calculus course, still on differentiability. Gradually we're going into the deeper parts of differentiability. In this class you're going to consider composite functions, chain rule, then derivatives of inverse functions. We did derivatives of inverse function in the introductory parts, but we didn't prove how we got those formula. In this class, we're going to learn how to prove for those derivatives. Kindly watch this video to the end so that you understand every part of the video. Don't forget to like, subscribe, and also share. Composite functions. When you say composite shape, having different parts. So if I have a function which has another function within, then I'll say that function is composite. Now let's see this function. If I have a function, let's say 2 open brackets 3x plus 1 all squared. Let's say all squared. Now see this function, f of x is equal to this. This function is said to be composite function. Why? I can get two different functions from this. I can get a function like 2x squared and a function like 3x plus 1. So if I replace this x with 3x plus 1, I'm going to get 2 open brackets 3x plus 1 all squared. Now makes it a composite function, a function within another function. Another example, you can have sine of 2x. 2x is a function, a linear function, a monomial. Then when I put it into sine, I get a composite function. I can get sine cube of 3x. This is a perfect composite function. So how do we go about the differentiation of this composite function? Then we apply another rule called the chain rule. So what the chain rule is, as you know, literally when you say a chain, something which is being joined together. So we're going to have a different steps in finding the derivative of this particular composite function. So let's see how you're going to do that. Let's see. If I have a function, say y is equal to f of x, let's say f of g of x, let me say that way. So this is the inner function and this is the outer function. So a composite function which is y is equal to f of g of x. If I'm to find y prime or dy over dx of this, then I'm supposed to differentiate this, then I'll multiply it by the differentiated form of the g of x. G of x. So what do I do? Let's see. If you have y is equal to f of g of x, then you are going to get this expression. So the y over dx should be equal to, you are going to solve for. So this one, we can't apply what I want to say here. So let me take a particular example so that you understand what I'm saying. So if I give you f of x to be equal to cos squared s cubed plus 4, let's see how we do this. This is a composite function in that we have a cubic function in the argument of a cosine function, where the cosine itself is also two cosine functions multiplying each other. So let's see how we solve this. Chain rule. First of all, we are going to use letters to represent the inner variables or the inner functions. So let u be equal to what I have inside here, s cubed plus 4. Once I get u to be equal to s cubed plus 4, I will differentiate u. So the u over the x will be equal to 3s squared. I put it down. Once I make u to be this, my f of x will be equal to cos squared u. Cos squared u. Now, cos squared u is also a composite function. Cos squared u is also a composite function in that I can also make this whole thing, let v be equal to cos u. When I make v to be equal to cos u, I'm going to get the v over the u, because now I'm having u here, will be equal to negative sine of x. Then I have negative sine of x as the derivative of the cos u. So right now, my f of x is simply equal to v squared, because v is the cos u and it is v squared here. So once I have v squared, I can go ahead and find the f of x, which I'll say dy over dv to be equal to 2v. So now let's see, I'm having the u over the x 1, the v over the u 2, then the y over the v 3. So at this point, let's see how the chain rule is. In the main question, you ask yourself, what is the question asking me to find? The question said we should find the y over the x. You put it down. Should be equal to. The next thing to do is, in our chain rule, after simplifying the chain, we should get back the y over the x. So first thing you have to do is to write the y up here. Then you ask yourself, in my three functions, which one has the y, which is this? You bring it the y over dv times, it follows, the v will, this dv will come up, you write dv, then you realize the v here is over the u, then you write over the u, then the u will come up times the u, then what is the u? The u over the x, then it ends there. So you realize that this dv will cancel this will cancel, and you get the y over the x back again. But we are not going to cancel, but rather going to multiply them. So my y over dv here is what? 2v, multiplying the v over the u, negative sine x, then also multiplying my u over the x, 3x squared, where this is equal to 2vx 3x squared multiplying negative sine of x. Let me still further simplify. Now my v I know is to be cos u, so I'll say 2 cos u. My x and this will give me 3s cubed. Then I'll put my negative here, sine x. I'm still not done. This cos u, or the u there, is s cubed plus 4. So I'll say negative 2 cos the expression s cubed plus 4 multiplying 3x cubed sine x. Where this still goes down again, negative 2 multipliers, so again negative 6x to the power 3 cos s cubed plus 4, then sine x as my final solution. So this is how you go by the chain rule. The chain rule can be long and messy at times, but make sure you take your time and you simplify it very well. Now let's do that of the derivative of the inverses. Let's take the first one, ln x. Ln x. Okay, so when we have ln x, how do we solve ln x? So what you are going to do is, ln x in a function form will be y is equal to ln x. If I want to differentiate to y, but the ln here, I can't do anything to it, but what I'm going to do is, I'm going to express this in the exponential form. So this is the same as, you know ln is logarithm with the base e, so e to the power y should be equal to x, exactly. And now I tend to get an exponential function here. So once I get this exponential function, I'm going to differentiate both sides with respect to x. So I'm going to get here, when I differentiate this, I'll still get e to the power y. Then I'm going to get the y over the x is equal to 1. The reason why I introduced this dy over the x is that when I'm differentiating both sides I'm differentiating both sides with respect to x. So at this point, I could also write the x over the x. So here, the variable here is y, so times the y over the x, here times the x over the x, but this will cancel. That's why it should be 1. So my dy over the x will simply be equal to 1 over e to the power y. 1 over e to the power y. So what is e to the power y? From this expression, you realize that e to the power y is what? X. Therefore, my dy over the x is simply equal to 1 over x. That is how we get the derivative of logarithmic function ln x. Let's see that of sine x, the inverse of sine x. So if I have y to be equal to sine inverse of x, how do I solve this? You know that if you have sine an angle theta is equal to 0.5, then sine inverse of 0.5 should give us theta. So here sine y should give us x. Exactly. At this point, I differentiate both sides with respect to what? X. Here, when I differentiate this, I'll get cos y. Then you multiply times the y over the x because I'm differentiating with respect to x. Is equal to x here. I'll differentiate it and I'll get 1 times the x over the x, where this will eventually cancel out. Then I'll finally get the y over the x to be equal to 1 over cos y. Now what is y? From this expression, I know that sine y is x, but how will I get y? From the identity, sine squared y plus cos squared y is equal to 1. I can say that my cos squared y is simply 1 minus sine squared y. Hence, the cos y is simply equal to the square root over 1 minus sine squared y. Where the sine squared y here is x. So my cos y is simply square root of 1 minus what? S squared. Therefore, I'll get my dy over the x to be equal to 1 over the square root 1 minus s squared. This is how we got the inverse derivatives that we solve. We're going to solve more and prove more in the next classes. Thanks for joining this class. Don't forget to like, share, drop your comments in the comment box. Thank you.